You are welcome to this episode of Physics to the World Made Easy with Tifa. Of course, the topic for us today is dimension of quantity. Okay, let's see the question. We have which of these is the dimension of power? Previously, in secondary school and in tertiary institution, the mostly used method is the use of formula for that very quantity to find the dimension, but it's becoming too tedious. It's too long to be done. Okay, I have been able to devise a new method, which is the use of units. If you can get yourself familiar with the units of power, I mean the unit, the simplest unit that contains dimension symbols, all you need to do is to just turn this unit to the dimension. What do I mean by that? Let's start this way. Power has a unit called watt. Okay, now but before that, remember that there are something we call dimension symbols. There are basically four in number. For mass, we have it to be capital M. For length, capital L. For time, capital T. And for current, capital I or capital A. Are we together? So I will learn this, then let's go back to this. So watt, if you check what is here, it doesn't have anything to do with watt. So all we need to do is to break down this unit into the simplest unit. And of course, watt here from the formula of power, which is work over time, we can see that work is joule, then over means per, that is per second. This is another unit for power aside watt. Of course, we've come across seconds, which is talking about time, but joule is unknown here. We have to break it down as well. Joule is for work and work is force times distance. Of course, from here we can break joule down to Newton, the meter for distance, then per seconds. We've come across meter, which is for length, seconds for time, but Newton is nowhere to be found compared to this. So all we have to do is first we have to break it down, going to the formula F equals to ma, which is the second equation from second law of Isaac Newton. So this Newton, we can actually break it down from m, which is kilogram, acceleration, which is meter per second squared. But remember, beside it there's another meter, and beside it there's times s raised to the power minus 1. So all we have to do is to use law of indices m, pick 1. This is power 1, power 1. According to that law, when you have similar base, you pick 1, then you add the power. 1 plus 1 will give you 2. Pick 1s as well. There's multiplication in between, then add the powers. Minus 2 plus minus 1 will give you minus 3. Now, I was not meant to have actually stressed this much. Adding being you are familiar with this unit of power, you will note that from this end here, you can get the dimension this way. Kilogram is the unit of mass. The dimension of mass is m. So change kilogram to m. Meter is the unit of length. Dimension of length is capital letter L. Take that, but m is having square. Of course, you put there. Now, seconds is the unit of time. The dimension symbol for time is t raised to the power minus 3. This is the dimension of power. And of course, coming back here, option A is the correct answer. Thank you for watching.